All right, 5.4, graph linear functions using slope-intercept form. Please bear with me because I am making this on my computer with the inking tool, and if something erases, I will try to rewrite it. Okay, slope-intercept form is a form we've actually been using a couple of times throughout this year when we solve literal equations and when we graphed using tables. The slope-intercept form of a linear equation is y equals mx plus b. Okay, when we solve literal equations, we put them in this form, and that's why I had you all put the x before the constant or the number that we had, because this is an actual form we use for linear functions. Okay, in this we have m, which we've already studied is the slope of our line, and b is the y-intercept. So I'm going to write this as an ordered pair as 0, comma b, because our y-intercept is always where x equals 0 and our y value is where it's crossing that y-intercept at. The first three problems we're going to do, we are just identifying the slope and the y-intercept. So this first problem being y equals 1/2 x minus 5. We can see here in slope-intercept form that the one attached to x is 1/2, and that is our slope. So I'm going to say m equals 1/2. All right, and then I can notice in my y-intercept, it is actually a -5 because in our formula it says plus b. Well, if that is a minus in front of it, then our number is actually going to be a negative. So I can say that my y-intercept is 0, -5. Okay? All right, number 2. You can notice with this second equation here that it's actually not in the correct form. You can still pick off the slope and the y-intercept without having to rearrange it, but if you would like to, I'm going to rearrange this to y equals -2x plus 6, because we can see here that -2 was in front of the x, and so if I put that up front, that's actually the part for my slope, and my 6 in the equation is a +6, so I put plus 6 at the end, which makes it very easy to identify our slope first. I'm put m equals -2, and our y-intercept in this one is +6. So I'm going to write my ordered pair as 0, 6. All right, and my third problem says y equals x minus 1/3. Now, the coefficient in front of x, if x is there, there is a coefficient that is kind of absolved into that x, and that is a 1. So if you want to put a 1 in front of that x to remind yourself there is a 1 coefficient in front of it, that will help you pick off your slope. So for this one, I'm going to say m equals 1, and my y-intercept is 0, -1/3, since it was -1/3 at the end of my equation for b. Okay, now that we can pick these off of an equation, we're going to actually make sure we understand what slope-intercept form is and how to put it in the correct form. So our first problem that we're going to do is 2x, oops, hang on one second, bring you back up. Okay, 2x minus y equals 7. Okay. To get this form, we did these in literal equations a lot. We are going to get this equation to get y equals. So the first thing I have to do is move my 2x term to the other side, and since it's positive, I'm going to subtract 2x. Now, the importance in the next step is 2 things. We need to remember there is still a -y out in front here, equals, and we want to make sure this always looks like it's in the appropriate slope-intercept form. So I am going to put that -2x before the +7 constant, Because if you go back to the top here and look at that form, it's always y equals mx plus b. And that mx has to come before the b to be in slope-intercept form. Okay, my last step to get y by itself is to divide by -1. And so my equation now is y equals, and -2 over -1 will give me a positive 2x, and 7 over -1 will give me a -7. So this is now in slope-intercept form, and if you want to just see verbally that the slope is 2 and our y-intercept is 0, -7. But you couldn't see that from this original equation up here because it was not in that slope-intercept form. All right, number 2. We're going to write out y minus 1 equals 2 times the quantity of x minus 4. Okay, in order to get this one to be y equals, we need to first distribute that 2. So now I have y minus 1 equals 2x minus 8. My last step is to add that 1 constant to the other side. And I'm left with y equals 2x minus 7. Same equation as the first one, actually. We have a slope again as positive 2 and a y-intercept of -7. But given that different form, we'll learn about that form later, it's not in slope-intercept form, so there's no way of knowing the slope at that point and knowing what the y-intercept was. All right, and number 3, I have 7x minus 2/3 y equals 4. Okay. There's multiple ways of doing this. We did plenty of these when we did literal equations, and I let you all choose which way you wanted to solve. So one of the ways we can do this is go ahead and move over the 7x and then get rid of the fraction, or we can get rid of the fraction early. Now, in order to get rid of this fraction of 2/3, I'm going to multiply my entire equation by that denominator, which is the LCD of 3. Just make sure when you multiply this, you multiply every term in the equation. So now I have 21x minus 2y, because the 3's will cancel, equals 12. Now it looks very similar to our problem from number 1. The first step from here is to subtract 21x. So I have -2y equals -21x. Remember to put the x variable first, and then your plus 12 constant at the end. My last step is to divide everything by -2. And my equation is y equals, now this -21 over -2 is a positive 21 over 2x. Since that does not simplify any further, and 2 does not go into 21 evenly. And then 12 over -2 gives me a -6. Now the last thing we need to remember if we are given a problem that's not already in slope-intercept form is that slope is always written as an improper fraction. We have talked about this a little bit throughout this chapter, but the main reason we need this as an improper fraction is because when we get to graphing, we need to know that slope is our change in y over change in x. So if you were to write 21 over 2 as 10.5, that writes it as a unit rate, but that doesn't really tell us a good point about movement, and this one would be up 21 over 2. So we really need to know that improper fraction of just one single number, change in y, over the single number for change in x. All right, so let's get some practice in with graphing the slope-intercept form. Our first problem is y equals 1/2 x plus 1/3. I knew that'd disappear on me. Okay, so I'm going to get to graphing this function, and it's kind of ugly with the fractions, but we can graph this. Notice here, I'm going to write out to the side, my slope is 1/2, and my y-intercept is 0, 1/3. So the first thing that we're going to graph is our y-intercept. So we need to know where it's crossing the y-axis at. And on this case, it is on 1/3. So I'm going to put a dot. I apologize for it not being a great graph on here, but this is what I have to work with. This is about where 1/3 is at, so put a dot right there for your 1/3. And then after that point, we can graph our slope of 1/2. From that point, I'm going to go up 1 and over 2, which puts a dot right here on my graph. We can do it again, up 1 over 2, up, and that's not perfect here, right there, up 1 over 2. Now don't forget with slope, we can also go backwards with this. So if it is positive 1, positive 2, we can also graph this by doing negative 1 over negative 2, because that would keep our slope still a positive 1/2 from negative over negative. So from that point, I'm also going to graph down 1 and to the left 2. And notice that that point also falls on this line. Same thing, down 1 and back 2. So all of these points fall on this line, and then we can graph our lines. Please forgive me for how horrid that line is. Hang on. Oops. Hopefully your line looks a whole lot better than that one does, because you have your rulers. Okay. So we have graphed this line using slope-intercept form. Your second equation is y equals negative x. And that's it. Okay, so analyzing this one, we noticed first that if you want to add in that coefficient of 1, if you don't see a number there, so in front of x, we have our slope is negative 1. And notice we have nothing added or subtracted to the outside. If you want to add in there a plus 0, that will help you remember that that still is a number. Even if nothing is added or subtracted to the outside of this problem, our y-intercept is 0, 0. So I'm going to start by plotting the point 0, 0. And from that point, I'm now going to do my slope. Now, what might help you when you do your slope is writing that negative 1 slope as a fraction, rise over run, or our change in y over change in x. You can make any whole number a fraction by putting it over 1. So now I'm going to graph down 1, and since it's over 1, it's a positive, so I'm going to go to the right 1. And then I'm going to go down 1 over 1, down 1 over 1, and I can do the same thing going backwards. Instead of negative 1 over 1, I can actually move that negative sign to the bottom because it's equivalent still. Positive 1 over negative 1 is also a slope of negative 1. So this time I'm going to go backwards by going up 1, but to the left 1. And notice that these points will all fall on the same line. Positive 1, negative 1. And then I'm going to draw my line through those points. All of these graphs do have arrows on them, notice, because we do not have any restrictions on the domains. All right, number 3. Y equals negative 3. Looking at this equation now, we're missing something. We're missing the mx in our slope-intercept form. So here, I'm going to write to the side m equals, well, the only thing that would make that x disappear is our slope being 0, because 0 times x would just completely make that disappear. And then I do have our constant term on the outside as -3, so my y-intercept is 0, -3. So I'm going to start by graphing 0, -3. It's going to disappear, but I'm going to redraw it. Okay, and then my slope is 0. So if you remember our slope being 0, that was our horizontal line. So from there, I'm going to draw a horizontal line on -3. And then you can also think about when we did have that slope of 0, we rose nothing, but we could run any amount. So if you just put 2 points on this graph, you can see that you would rise none and move over as many as you needed. So here our y equals -3 is our horizontal line on -3. Okay, let's move to the back page. All right, now these examples, we're going to start with 8x plus 4y equals 10. All right, so the first thing we need to do with these examples is we need to get these in slope-intercept form. So the first thing I'm going to do is I'm going to subtract 8x and I have 4y equals -8x plus 10. For some reason it does not want to write that plus sign. Okay, and then I'm going to divide everything by 4. And so I have y equals -8/4 would simplify to -2x, and 10/4 would simplify to 5/2. Now my last step before I get to my graphing is actually deciding what my slope and my y-intercept are. Well, the slope is attached to x, so my slope is -2, and my y-intercept is the constant, my b on the outside, so 0, 5/2. Now, sometimes you can think about that 5/2 being that fraction, but sometimes it's also easier to write it as a decimal. So 5/2 is the same as 2.5, and that is easier for putting a point on the graph. So I'm going to start on, it's not going to let me write my 5. I'm going to start on 2.5, so up 1, 2.5, and this is my y-intercept. Okay? From that point, now I have to do my slope. And remember, since our slope is a whole number of -2, and you want to know what your movement is going to be with rise over run, you can always put your whole numbers over 1. So from there, I'm going to go down 2 over 1. Okay, and you can go another down 2 to get another point over 1. You can also flip where the negative is at. So I can actually go +2, but then I have to go left 1 in order to give this problem a negative sign. You only really need 2 points to graph this, but if you want your line to be very straight, you can graph a couple of points, and you can actually graph all the points on there, all the way from endpoint to endpoint. Connect your points and draw your arrows on your line. Okay. Number 5. Your problem is 2x minus 2y equals 0. First thing we're going to do with this is we're going to solve for y. Put this in slope-intercept form by first subtracting 2x from both sides. Notice here I have a +0 at the end. I'm not going to actually write this in anymore because I don't need a +0 for that constant term. And then I'm going to divide by -2 to get y by itself. and I end up with y equals x. All right, so picking off my slope, don't forget if there's no number in front of x, it is a positive 1. So my slope starts off with as m equals 1. And my y-intercept with nothing added to the outside, once again, if you'd like to put, you can put a plus 0 in there. You can put your 1 for the coefficient, but my y-intercept will be 0, 0. So I'm going to start my y-intercept on 0, 0, and then I'm going to graph my slope of 1. Still, this is a whole number, so I'm going to put it over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. You can also graph this, since this is a positive number, you can make them both negative as you graph the slope. So down 1, left 1, down 1, left 1, and keep graphing that way. Connect all your points, and you have your graph. All right, number 3. Your problem is 3x minus 2y equals 7. Go ahead and pause the video and then hit play when you finish and check your work. Okay, so looking at this problem here, we have, oh, hang on one second. All right, so first subtracting 3x from both sides, I end up with negative 2y equals negative 3x plus 7. Then I divided both sides by negative 2, and I got y equals 3/2 x minus 7/2. Okay, so my slope is 3/2, and my y-intercept was 0, negative 7/2, or I wrote out as 0, negative 3.5. Looks kind of messy, but I had trouble writing my 3. Okay, and hopefully your graph looks a lot straighter than mine does, but I did start off my y-intercept on negative 3.5. And from that point, I went up 3 and over 2. So I graphed a couple points afterwards, and then I drew my line through it. All right, so last thing we're going to do is we're going to move on to some word problems. So the first one says, Monica gets on an elevator in a skyscraper. The elevator starts to move down at a rate of 20 feet per second. Monica starts on the floor of the skyscraper at 200 feet. The total distance d of t in feet is given by this function. D of t equals 200 minus 20t, where t is the time in seconds. Notice your equation here is not in slope-intercept form because they are flip-flopped this time again, where the slope and the y-intercept are located. You are more than welcome to rewrite this, and I'm going to go ahead and rewrite it out for you. Of d of t, let's go back to that. Equals negative 20t plus 200. Now, if you can recognize it and leave it in the format that's given, you're more than welcome to leave it like that if they give it in a different format other than in the slope-intercept form with slope first and then the y-intercept. Okay, so we are going to analyze this problem. The first one says, what does the slope mean in the context of the problem? Well, my slope is negative 20. If you notice it in front of your t variable, instead of x, it is t in this problem because we have distance versus time. In negative 20, well, we can reread through the problem and it says the elevator begins to move down at a rate of 20 feet per second. So that is describing that negative 20 in your slope. So I can say something about the slope, meaning the context of the problem, that Monica is going down This is going to be a lot harder than I thought to write the sentences, but please listen to it verbally. Monica is going down 20 feet per second. Okay. What does the y-intercept mean in the context of the problem? Well, my y-intercept in the equation is positive 200. we can reread the problem that it says Monica starts on the floor of a skyscraper at 200 feet. So this is where her starting point is. Monica starts at 200 feet. Oops, let me erase that. Monica starts at 200. Oh, and it just moved me again. I don't know why it keeps moving me down now. Maybe my arm keeps hitting it somehow. All right, let me move back up to the top now. Monica starts at 200 feet. Part C says graph the equation. Well, if you notice that my graph actually already has a scale on it, that's because I knew I would struggle a lot with this writing pen. So just take a moment and write out your scale. The X values I scaled from 1 to 10. Each single mark is represented by 1 unit. The Y values are scaled from 0 to 200, but this time each scale is based off by 10. I went ahead and only labeled every other mark, which is 20, but that would make every one mark represented by 10. Okay, so when we graph an equation though, you do have to scale your axes, and the next thing you do is you always have to label. Well, we know that the distance is given in feet. So I'm going to label my y-axis, my distance, as feet. And then we know our x-axis is time in seconds. So I'm going to label my x-axis, or my t-axis, as seconds. Okay. So we know Monica started off, and our y-intercept is 200. She started off 200 feet. So I'm going to first put a dot on my y-axis at 200. And then I'm going to do my slope, which is -20. And remember, if it's a whole number, you can always put it over 1. So my next point, if I go down 20, which is 2 marks going on the y-axis, and over 1, it puts me at 1/180. I'm going to do that again. I'm going to go down 20 over 1, down 20 over 1, and I'm going to keep graphing this until I get to the end of my graph. Now, this is a real-world situation, so I'm not going to go up 20 and left 1, or else that's going to put us in negative time. I'm also not going to go past, when I hit 0 feet here, I'm not going to go past it and try to go even further, because once again, you can't have 0 feet. Or you can't have negative feet. So this is going to continue to stay in the first quadrant. And then I'm going to connect my points, because this actually is a continuous function with time. And then I'm going to answer my last question. At this rate, how long will it take after Monica enters the elevator for her to exit the elevator on the ground floor? Well, we can clearly see, given on our graph, that right here, she is hitting ground floor at 0 feet, and that in seconds is 10. So this will take her 10 seconds. All right. The next one we have, an investor invests $500 in a certain stock. After the first 6 months, the value of the stock has increased at a rate of $20 per month. The function y equals 500 plus 20x represents this situation. Graph the situation. All right, I'm going to let you all pause this video. I've given you the scale. I've given you the labels. Notice here is a little bit break in the graph. And that just means that they kind of broke off. Instead of starting off one tick mark being 20, they did not start off on 20. So that's what that break means, a little zigzag line. All right, go ahead and pause the video and graph this function. All right, so you could have taken your equation and put it into the slope-intercept form of y equals 20x plus 500, or you can just notice that this 500 is the y-intercept, and then it went up 20 over 1. So I graphed up 20 over 1, and I did put an arrow at the end of this because it doesn't say how long that they are investing their money, and time can go positively, so I put an arrow at the end of this. However, I did not put an arrow on the left side because time cannot go negatively, and you can't go into that negative amounts unless, I guess, technically you could owe someone, but I did not put it in that because time cannot go negative in the months. All right, so that was just practice graphing a real-world situation, and now we're going to work on the last problem. You can use a laser or inkjet printer to print an 18-page report. The laser printer prints 6 pages per minute, and the inkjet printer prints 4 pages per minute. The model gives the number of pages P left to print after T minutes. You can see there my thing got off a little bit. That's okay. All right, so the first thing it tells us is it tells us the equations for the laser printer, and it tells us the equation for the inkjet. So the first part says graph both models in the same coordinate plane. Notice once again I have scaled my axes. So take a minute to scale your axes. The x-axis go up by 1 each time. And the y-axis I've labeled going up by 2 for each mark. The last thing I'm going to do for the graph is I'm going to go ahead and label this. And I know that my t is in minutes, so I'm putting my time in minutes. And my p is the pages left to print. All right, so graphing these two functions, the first one I'm going to actually graph mine in 2 different colors. I'm going to put my laser in red. So starting off with my laser printer, I can start off my y-intercept in that equation is 18. And my slope is -6. Now these are not going to be perfect problems for this, but we can go, oh, this will be good. Down 6. And remember, whole numbers we can put over 1. So I'm going to go down 6 over 1, which would put me at 112. Down 6 over 1, which would put me at 26. And then down 6 over 1, which would put me at 30. And I'm going to graph that function. Notice once again, I'm not going into the negatives because you can't have negative time, nor can you have negative pages left to print. Okay. My second graph, I'm going to go ahead and graph this one in green, my inkjet. So this one also, it's just an 18-page paper report that you are comparing. So this y-intercept is also on 18, but the slope is on 4.5. So my next one down from that would be 13.5. Okay. My next point down from that would be on 9. Next one down from that would be on 4.5. And the next one down from that would be on 40. And I just realized that your scale, you could have had those half marks in between. The one I had gotten, it does not have the half marks in between. Okay, so as curvy as those lines are, we do have here our inkjet printer now on there. And part B says, By how many minutes do you save by using the laser printer? And I don't know why that Z ended up there. I think I accidentally typed that in. So how many minutes do we save? Well, if we notice in red, our laser is ending at the 3 minutes. So we'll take 3 minutes to use the laser printer. Our inkjet, though, because it was a slower pace, it ended on 4 minutes. So you are saving 1 minute. So you save 1 minute using the laser printer. All right, thank you for being patient with me on this. You do have your homework that corresponds to this, and this will be posted in Canvas from now on. So if you need to refer back to any parts of this notes, please refer back to them. Thank you. Have a good day.